Hi everyone, today we'll be talking about indexing in databases. Hi everyone, today we'll be talking about indexing in databases. Specifically, we'll be talking about NoSQL databases. Because the traditional relational database indexing has been covered thoroughly. I have the links in the description below. The main thing which is different in NoSQL databases is that there's the concept of a key. There's a concept of a hash.
It's about 1.9 I'll apply my Brave. And I'll say, okay, probably let's keep the row as row. So I'll keep the row as row. Perfect. And the column I'll take space complexity is nothing but big O of n and big O of m for the two arrays that you're using for hashing. This is where the interviewer will not be happy because you're using an extra space and he will ask you to optimize the better solution and you will move to the optimal one. Over here, can you optimize the time complexity? We are already doing it in the order of n square. And we know the minimum in order to traverse a matrix can be n square. You cannot do better than that. That's why we will be focusing to optimize the time complexity. And let's get back to the matrix. We were taking a column and we were taking a row. Agreed? So if I was taking a column and if I was taking a row, if I have to optimize it, what does that mean? That means you have to do everything in the matrix itself. So what I'll start thinking is, can I keep a track in the matrix itself? Can I just probably keep a track in the matrix itself? And that's when I start thinking, what if I say, hey, maybe instead of taking a row outside, what if I consider the first column to be my row? Like instead of taking here, I moved it inside. Probably in place, I moved it inside. So what I'm saying is, row or at the column of 0 will become my row, which I was taking. Probably yes. And now I'll say, probably instead of taking this, I'll move it inside. Maybe because I have to do it in the matrix. So that's a possible solution. The row 0 is what I will now consider as column of m size. That's my first assumption. But can I take it? Let's see if that's possible. So what am I saying? The things that I was marking here, like for the 0, if I was marking here, instead of marking here, I'm taking this and I'll mark it here. That's what I'm saying. Correct? But is it correct? So I'm asking you the third element. So that is 6. Six, 3 plus 1, 4. So basically 3 plus 3, 6, and 3 plus 1, 4. If I go ahead, one at the start, one at the back, and then one middle here, one middle. So there are 4 middles. Add it up 5, 10, 10, 5, and you can keep on going. And this is what the Pascal triangle looks like. So if you go to an interview, there can be 3 types.
गेट लॉस बड़ी बोलने के बाद भी नादान है बेचारी।
Types of problems that might be asked to you. The first one is super simple. Given the row number, given row and column, tell me the element at that place. Tell me the element at that place. What does it mean? Imagine I give you R equal to 5, C equal to 3.
बाद भी नादान है बेचारे। गेट गेट लॉस बड़ी बोलने के बाद भी नादान है बेचारे। गेट लॉस बड़ी बोलने के बाद भी
So this is first row, this is second row, this is third row, this is fourth, this is fifth, this is sixth. So in the fifth row, I'm asking you the third element, so that is 6. So the answer to this will be 6. This is the first type of problem. What can be the second type of problem? They might ask you, print any nth row of the Pascal triangle. Nth row of Pascal triangle. Imagine I give you n as 5. So what will be the fifth row? It will be this one. So what you need to return is, you just need to return 1, 4, 6, 4, 1. This is the second type of problem. What can be the third type? The third type will be print the entire Pascal triangle. Given n, print the entire triangle. So imagine I give you n as 6. In that case, you have to print the entire triangle. Got it? So let us solve the first question. And the first question, it is stating, given R and C, you have to tell me the element at that row number and the column number. So one of the traditional ways is, you say that you're going to generate the entire triangle and then get the value at R and C. And that kind of makes sense. And that is the brute force solution, which we will be doing at the third type. But do we have an easier way? Yes, we do have. There is a very simple formula to it. So if you're given the row number, then you do an R minus 1. And if you're given the column number, you do a column minus 1. And you say R minus 1 combination of C minus 1. So I'm sure that you know the NCR. So in mathematics, NCR is nothing but n factorial by R factorial into n minus R factorial. I hope you know that, right? And how do you find this out easily? Because over here, we know for this, the answer is this. So if you're given 5, what you'll do is 5 minus 1 is 4. C minus 1 is 3 minus 1 is 2. So the answer is 4C2. And the value of 4C2 is nothing but 4 into 3 into 2 into 1. According to n factorial, what's the value of R factorial? 2 into 1. And then it says n minus R, which is 4 minus 2. So another 2 factorial. It's basically 2 and 2 gets off, and 2 and 2. So the value is 6, which is ideally the value. If you carefully see, that is the value, right? So we know the formula, but how do you find it out? One of the easiest ways is, you figure out n factorial, you figure out R factorial, you figure out n minus R factorial. And what you do is, numerator by denominator 1 into denominator 2. And you know how to find out factorial. That's a very simple step. If you said n factorial, you run a loop for n. If you said R factorial, you run a loop till R. N minus R till n minus 1. So the simplest way to find out this value NCR is nothing but just n factorial, R factorial, and you just run loops. But that is the extreme brute force. Can we have a shortcut? We can. Let's have some observation. Imagine you give it 7C2. Formula states 7 factorial by 2 factorial into 7 minus 2, which is 5 factorial. This is what the formula states. So if I have to write it, can I write it something like this? 7 into 6 into 5 into 4 into 3 into 2 into 1. 7 factorial is this. 2 factorial can written as 2 into 1. Into 5 factorial is 5 into 4 into 3 into 2 into 1. Can I say this and this will go off always? And the remaining values will be 7 into 6 and 2 into 1. Something carefully to observe. this one went for two places, like 2 into 1. So from 7, you go two places. So what is the shortcut that you noticed? If I take 10C3, what you'll always do is, you will say 3 went 3 places. 3 into 2 into 1. So 10 will also go 3 places. 10 into 9 into 8. So this is the shortcut that you will be applying. Okay? But make sure when you compute this using for loop, you should be computing from, like, in the sense, 10 by 1 into 9 by 2 into 8 by 3. Why is that? Because if you initially take 3 and you try to divide by 10, that will give you nothing. But if you initially take 10 by 1, it is divisible. Then if you take 10 into 9 by 2, 2 will kind of divide it. And then if you take 3, in 3 numbers, 1 will definitely be divisible by 3. And hence, it will be easier. So what will the code look like? Can I say, I know definitely one thing. If it is 3, I'll run it for 3 times. So let's go ahead and run it for 3 times. So can I say I equal to 0 and I'll run it till whatever, like if I have to write, probably I'll write the function. That will be a better job. So imagine I write a function which finds me NCR, and it is taking N and it's taking R. Okay. And what we say is, okay, we have a numerator, or rather we can have a resultant as 1. Let's have a resultant as 1 and we run a loop from I equal to 0 and we will run till R. Okay, why? Because we know that if it is 3, we just run 3 times. So I'll run it like this. And initially what we will do is resultant equal to resultant into, if you carefully see, initially it was 10, which is basically n, right? And then it was 9, which is basically nothing but 10 minus 1. Then it is 8, which is basically 10 minus 2. So whatever this I is, what you'll do is you'll say n minus I, because the first time n is 10, so 10 minus 0 will be 10. At the next time, n is still 10, but I is 1, so it will be 9. So the numerator keeps on getting multiplied. And what you do is, once you've done the multiplication, you will go ahead and divide it with what value? It's going to be very simple. You say I plus 1. Why I plus 1? Whenever I is 0, the first time you take 1. Then whenever I is 1, you take 2. Whenever I is 2, you take 3. So apparently what will happen is, first time 10 and 1, then 9 by 2, then 8 by 3. And this will be done. Once this is done, you can return the result. And this will be your extreme brute force. If I ask you the time complexity, can I say the time complexity will be very simple? We're running a loop for big O of R. So in order to find NCR, the time complexity taken is big O of R and the space complexity taken is big O of 1. Please do not go ahead and run a loop like this, because this will be n factorial. If you go ahead and run a loop, it will take big O of n plus big O of R plus big O of n minus R, which might end up taking a lot of time. And also when you calculate n factorial, the values might be very big. Also remember one thing, for such problems, it's always safer to take the largest data type as long, so that there is no overflow. Got it? So I've written my function NCR. Now in order to solve the first type, what I'll say is function NCR R minus 1 and C minus 1. If I pass these couple of parameters, what will happen is this NCR will find me the value of R minus 1 and C of C minus 1 and will give me the answer. And this is how you can easily solve the first type of problem. Now let's move to the second one. So what is the second type of problem state? stating print any given row. So imagine you've been asked to print the sixth row. Let's carefully observe something. The first row has one element, the second row has two elements, the third row has three, and similarly the sixth row has six elements. Can I say n row, like the nth row rather, nth row will always have n elements? I definitely can say that, right? So this is what we know at first, that we have to probably run a loop for n times. Now we know one thing for sure, everyone has this formula of r minus 1 and c of c minus 1. We know that. So what we can do is, the extreme brute force can be super simple. We say we know one thing for sure, the column will start from 1 and the column will go till the number of rows, and then we can do a column plus plus, and every time we can say rather print not cout, we can easily say print, we will call the function which computes ncr, and what we will pass is, we will pass the row number which is n minus 1, and we know the formula is c minus 1, so c minus 1, and every time c changes, because for the first time c will be 1, then c will be 2, and apparently it'll keep on printing this one, then this one, then this one, then this, then this. So what will be the time complexity for this? Can I say we are running a loop for n times? So it'll be n, and we know this function takes big O of r. So the time complexity will be n into r. This is where the interviewer will not r, right? So this is what we know at first, that we have to probably run a loop for n times. Now we know one thing for sure, everyone has this formula of r minus 1 and c of c minus 1. We know that. So what we can do is, the extreme brute force can be super simple. We say we know one thing for sure, the column will start from 1 and the column will go till the number of rows, and then we can do a column plus plus, and every time we can say rather print not cout, we can easily say print, we will call the function which computes ncr, and what we will pass is, we will pass the row number which is n minus 1, and we know the formula is c minus 1, so c minus 1, and every time c changes, because for the first time c will be 1, then c will be 2, and apparently it'll keep on printing this one, then this one, then this one, then this, then this. So what will be the time complexity for this? Can I say we are running a loop for n times? So it'll be n, and we know this function takes big O of r. So the time complexity will be n into r. This is where the interviewer will not be happy. He'll be like, why are you using formula repeatedly? Can you do it in a better way? And this is where we will try to optimize it. Okay, so in order to optimize, we have to dive deep into the formula. The formula was r minus 1c and c minus 1, correct? So let's look at the first element. The first one is 1. Let's look at the next. It is 5. Probably I can write it as 5 by 1. Probably. What is the next one? 10. And that is at the third column. That's at the third column. What will be the formula? 6 minus 1, 5. C, 3 minus 2, 3 minus 1, 2. And it will be like 5 into 4, 3 minus 2, 3 minus 1, 2. And it will be like 5 into 4 and 2 into 1. Can I say the 10 is coming from here, which is this formula? I can. So what did you add more? Did you add 4 into 1 more from the previous value? You did. So this one is this. This 5. Add 4 into 1 more from the I can. So what did you add more? Did you add 4 into 1 more from the previous value? You did. So this one is this. This 5 is this. And this can be written as 5 into 4 and 1 into 2. I can. So we are done with the third column. It's time for the fourth column. In the fourth column, what will be the formula? N minus 1, 5. C, 4 minus 1, 3. 5, C, 3. So it will be like 3 into 2 minus 1, 5. C column. It's time for the fourth column. In the fourth column, what will be the formula? N minus 1, 5. C, 4 minus 1, 3. 5, C, 3. So it will be like 3 into 2 into 1. Correct? Or if I have to write it in the other way, it will be 1 into 2 into 3, and 5 will also go 3 times. So if you carefully see, what was the addition? This was already there in the previous one, and we just added this one. So, okay, fine. It'll be like 5 into 4 into 2 into 3 by 3. So there is an addition of this one. Okay, let's look at the next, at this one. So this is going to be like 5. C, what is this column? This is the fifth column. 5 minus 1, 4, 5C4. So 1 into 2 into 3 into 4, and 5 into 4 into 3 into 2. So if you carefully observe, this was the answer for the previous one. So as of now, you are saying, please add an extra, this 2 by 4. Amazing. And you can keep going. So if you carefully observe, at first 5 by 1 got added, next 4 by 2 got added, next 3 by 3 got added, next 2 by 4 got added. So if you start with answer equal to 1 at column 1, and at column 2, what happens? At column 2, you probably add a 5 by 1. And then at the next, you probably add a 4 by 2. And the next, you probably add a 3 by 3. So if you can somehow figure out a formula to do this, I think our job will be pretty much done. So let's try to figure out a formula. So what will be the formula? Let's try to think and see if we can analyze the formula. Something I know for sure. And what is the one thing that you know for sure? The one thing that I know for sure is the first element will be 1 and the last element will definitely be 1. So we don't have to think about the first and the last that much. But without it, we need to think about everyone else. Okay. So we probably can start with answer as 1. We can start with answer as 1. And in the first attempt, we're doing a 5 by 1. And the column number was 2. Column number was 2. So this is, okay, what if I take the columns in terms of zero-based indexing? Will it be an easier job? Let's see. So let's write down the zero-based indexing. This is 0, 0, 1, 2, 3, 4. Does it make it easier? Yes, it does. Over here 1 is here. Over here 2 is here. Over here 3 is here. Over here 4 is here. That makes it easy, right? And if you go ahead and write the next one, which is the fifth one, it will be like 5 into 4 into 3 into 2 was common. 1 into 3 into 4 will be common. The last one will be 5. This one will be 1. So can I say what we are doing is answer into whatever is this column. We're always dividing it by column. Column, 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 column. Whatever was the previous answer, we're dividing it by column. What are we multiplying? We're multiplying at first 5, then 4. It's like if nth row is 6, can you relate? 6 becomes 5, reduction of 1. 6 becomes 4, reduction of 2. 6 becomes 3, reduction of 3. Can I say it's n, which is the row number? Or probably you can write row number. Row minus column. Yes, this is what you have to keep multiplying. If you do this, you'll be able to generate the entire row. So if I have to write it, it'll be like, I know one thing for sure. Probably I'll write it again. I know one thing for sure, that for, rather, let's keep answer equal to 1. And I know one thing, that this will be my first. This will be my first. Because for the 0th row, I know the answer will, sorry, 0th column, the answer will always be 1. So now I will start from, for I equal to 1, this is where I start from. And I will go on till the last, which is n, because the last one is 5th index and n was 6, so we go on till this. Perfect. And what will we do? We will say answer equal to, first we will try to multiply. First we will try to multiply. What will we multiply? Obviously this one, which is nothing but whatever is n minus this I, because this is I, so minus. And then we will say answer equal to answer divided by I. Super simple. Once this for loop, like this for loop will always keep on printing, and this will print the entire thing. Pretty simple, isn't it? What did I do? I just kept on multiplying. First 5, then by 1. Then the next step, 4 by 2. I kept on generating, and we kept on printing. So eventually we first print this, then this, then this, and then this, and we'll end up printing the entire nth row of the Pascal triangle. Got it? If I talk about the time complexity, can I say the time complexity will be whatever is the number of rows, those many columns you have to print. So the time complexity will be big of n, and the space complexity will be big of 1. Quite simple. So you're done with the first and the second type. What about the third type? The third type is stating you'll be given n, and you have to print this entire Pascal triangle. Does it mean you have to give all these spaces? No, it's not pattern printing. What you have to do is, the first row is containing 1, so you return 1 in a list. Then it is 1, 1, so you return 1, 1. Next, 1 to 1. Next, 1, 3, 3, 1. Next, 1, 4, 6, 4, 1. Next, 1, 5, 10, 10. And this will be the answer if n is 6. And everything will be inside a list. And all of these lists will be put inside a list. And then this is what you have to return. So what is the extreme naive brute approach that you can think of? It's definitely using the formula r minus 1 c, c minus 1. What you do is, you know the rows will be from 1 to n. So you kind of run a loop from 1 to n for rows. And you know the columns will be c minus 1. What you do is, you know the rows will be from 1 to n. So you kind of run a loop from 1 to n for rows. And you know the columns will be from 1 to this current row. Why is that? Because for the first row it is 1 element. For the second row it is 2 elements. For the fifth it is 5 elements. For the row number, the columns are equivalent to the row number. So we know the answer will be a list which we have to return. So probably take a temporary list and take an answer list. Now what you do is, inside the inner for loop, temporary list dot add Ask the NCR function that you wrote in the first to generate the answer for every element, individual element, and you can add it up. Once this temporary list is generated, you can ask the answer to add this up, temporary list. And eventually, what you can do is you can return this answer. Yes, eventually you can return this answer, and this is how easily you can do it. By the way, the code for this, you can find it in the updated article in the description below in case you want to see the code for this. So what will be the time complexity? Can I say I'm running an n loop, another n loop, and this, if you remember, took big O of r. So it's near about, not exactly, near about n into r, near about, but it's near about big O of n cube in the worst way. Near about, not exactly, big O of n cube. We will not talk about the space complexity because we're storing the answer to return. We're not using it to compute. It is the answer which is stored. So the time complexity is this. Obviously, the interviewer will not be happy and he'll ask you to optimize it. So how can you reduce it from big O of n cube? So we will use the second type. If you remember, the second type, given any row number, was generating you the entire row. So we'll be using this to generate every row, and this was taking a big O of n complexity. So for every row that there are n rows, we will take big O of n to generate that row. The total complexity will boil down to big O of n square, and this is what will be the optimal solution for the type 3. Okay, so time to code the third type up. Again, the problem link will be in the description. Please make sure you try the problem from the link in the description itself. So what is the first thing you Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another video from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course when it comes to DS Algo. Why do I say that? Because this course has 450 6 modules. By the end of the course, you would have solved more than 400 plus problems when it comes to DS Algo. You can go across the entire internet. You can buy any of the paid courses in the market. None of them will be teaching you DS Algo in such depth. One thing that I can give you as assurance is, if you complete this particular course, you can clear any of the DS Algo rounds in any of the companies in any part of the world. So till now we have covered till this particular problem. In this video, I'll be covering the next permutation problem. So what does the problem next permutation state? It states that you'll be given an array of integers. It can be repetitive integers as well. Now, you have to find the next permutation of this particular array. But in order to understand next permutation, what you need to first understand is, what is permutation? Now, you're given an array and the array is containing integers. Over here, there are 3 integers. Now, these 3 integers can be rearranged in themselves. Now, imagine if I rearrange 3, 1, 2, can I write them as 1, 2, 3? I can. If I bring the 1 to the first place, if I bring the 2 to the second place, if I bring the 3 to the third place, I can write them as 1, 2, 3. I can also rearrange 3, 1, 2 and write it as 3, 2, 1. I can also rearrange 3, 1, 2 and write it as 2, 1, 3. So if I ask you, how many possible rearrangements are possible? You'll be like, for 3, 1, 2, since there are 3 numbers, 3 factorial, very basic maths, 6 possible ways. I can rearrange them in 6 possible ways. Now all of these ways are called permutation. Now the question is asking you to find the next permutation. Now, what does next permutation means? When I say permutation, all the possible ways, all the possible ways have to be written in the sorted order. So if you see one one, 2, 3 is before 1, 3, 2. Now, what do you mean by sorted order? If you go to the dictionary, can I say 1, 2, 3 will always be smaller than 1, 3, 2? 132 will always be smaller than 213. Dictionary order, because 123, like 123 is smaller than 132. So you have to write them in dictionary order, in the sorted order, ascending way. Now you have to find where is 312. Can I say 312 appears here? It does in the sorted permutation. Now you have to find the next permutation after 312. And the next permutation is 321. So the answer to this that you have to return will be 321. Yes, this is what you have to return as an answer. Now you might be thinking of a possible edge case. What if the the array was given as 3 to 1. So can I say for 3 to 1, these will be the possible permutations. But if I have to write the next permutation, 3 to 1 lies over here. And if I carefully observe, there is no one after 3 to 1. So what will be the next? Because there is no one. In such cases, you will fall back to the first possible rearrangement in the sorted order. Hence, the answer will be 1, 2, 3. If there is no one after this particular arrangement, you'll fall back to the first and the answer will be 1, 2, 3. If this question comes up in an interview, the first solution that you'll tell the interviewer will be of brute force solution. Now, what is a brute force solution? It is generically doing what the problem states. The problem was stating to generate, like, if you normally think, it's basically generating all the permutations. So I'll generate all the possible permutations. Once you have done that, can I say you'll get all of them? You will. Then you'll be like, where does 3, 1, 2 lie? And make sure you generate all of them in the sorted order. Then it is like, where does 3, 1, 2 lie? So probably I can do a linear search. I can iterate and I can find that 3, 1, 2 lies over here. So do a linear search in order to find where does 3, 1, 2 lie. Once you have figured out where it lies, can I say the next index permutation, like this one, the next index permutation, this one, will be your answer? Yes, that will be my answer. If there doesn't exist a next, then the first one will be my answer.
じる。強い。待った。この勝負俺の負けにしよう。
しようとはなんだ、しようとは。
いや、陶器を背中に感じた。
この野郎、わけのわからねえこと言って試合を放棄する気かよ。
そうじゃない。試合は俺の負けでいい。
それじゃあ賞金はいただくぜ。
あんなに強い闘気を感じたことはない。
しっかりしろ。あいつら何者だ。
シャドルのテロリストだ。
シャドル。
お金余ったの？
わかったわかった、ありがとう。
いいよ。この金半分はお前の分だ。
金？
さっきの勝負お前がいなきゃ負けてたかもしれねえからな。とっときな。お互い日本の武闘家だ。遠慮するな。
Answer. Can I say the brute force will be comprising of these three particular steps? Yes. But now you'll be thinking, but how do I generate all the possible permutations? In order to generate all the possible permutations, you'll be using recursion. And I've already made a couple of videos on it. So there are two approaches. If you see the lecture 12 and lecture 13 from the recursion playlist, you'll get to know how to generate all the possible permutations. Now in an interview, you just have to mention these steps. Usually in an interview, you don't have to, because if you start coding the code for generating all the permutations in recursion, that will eat up a lot of time. That is why in an interview, you generally have to just say that this is what I'm thinking, generate all, do a linear search, and that's it. And that is when the interviewer will ask you, okay, what do you think will be the time complexity? I'm not diving deep into the time complexity. You'll find that in lecture 12 and lecture 13 of the recursion playlist. Let's just hypothetically
Hello guys. Actually, I am having a hairline fracture on my right hand. If you can see the swelling in this swelling. तो मैं ज़्यादा यूज़ ही नहीं कर पा रहा हूँ, ना लिख पा रहा हूँ इस हाथ से अभी तो. एंड अभी आई गॉट माई डिनर एंड आई विल बी एंडिंग दिस स्ट्रीम क्योंकि आई एम नॉट फीलिंग लाइक आई कैन नॉट जस्ट, पता नहीं अभी तो आई कैन नॉट. आई ट्राइड. So yeah, I'll continue this. Maybe off stream I'll do some more DSA वाले problems. And yeah, आज मैंने पास्कल्स ट्रायंगल वाला कर लिया था और सॉर्ट अरे ऑफ जीरो वंस वो वाला मैंने ख़त्म किया. ऑप्टिमल सॉल्यूशन मेरे को उसका समझ नहीं आ रहा था. सो आई थिंक आई एम गोना जस्ट स्किप द ऑप्टिमल पार्ट. अब वो मेरी इतनी बुरी किस्मत ही होएगी अगर इंटरव्यू में वही पूछ लिया मेरे से तो. बट या आई एम गोना स्किप दैट क्योंकि वो समझ में नहीं आता. रोज़ का कॉलम कॉलम का रोज़ थोड़ा स्टार्टिंग में ही लाइक इट लॉस्ट मी. एंड पास्कल्स ट्रायंगल वाला आई डिड इट. उसमें थोड़ा सा डायनेमिक प्रोग्रामिंग वाला यूज़ किया था स्ट्राइबर ने, तो उसका मैंने थोड़ा सा आइडिया लिया कि डायनेमिक प्रोग्रामिंग होता क्या है. कि पहले के जो हैं डेटा, पहले के जो रोज़ हैं उनका सेव करके रख रहे हैं एंड देन उसका बाद में यूज़ ले रहे हैं. सो apparently this is what dynamic programming is. So yeah, इतना है. और अभी मैं कर रहा था परम्यूटेशन, टोटल परम्यूटेशंस निकालने वाला. एंड वो मैं खाने के बाद कंटिन्यू करूँगा ऑफ स्ट्रीम. ये वैसे बहुत लंबी हो गई है. ओके, सो वीक 3 डे 1 एंड या कल मिलते हैं. बाय बाय.